Good evening, everyone. Welcome to Office Hours. I am the engineer. I'm your host. I'm also your advisor. If you have questions about how to get into industry as an engineer, what educational path you should follow, please do ask. You can follow me here on YouTube at Engineer IDE. You can also follow me on Twitter at Engineer IDE. Please leave your questions and comments down below in the comment section. I will respond. I'm interested to hear your thoughts, and like and subscribe, and please share if you find this stuff interesting. So today I'm going to share with you this article about computer science. We will be hold on one second here. I am figuring this out. Thought I had this all planned out. Apparently I didn't. So I'm looking to share. Okay. Share screen. That's what I want to do. This was not supposed to happen. All right. Here we go. There we go. We got this. All right. How about that one? Nice. All right. Computer science is no longer the safe major. I've learned to code. You've heard that before. Has lost all meaning in the age of AI by Kelly Maria Kordaki. This was published on September 26th. So it's about a month old. Let's make this a little bit bigger for you. All right. Maybe upside. Oh, that doesn't work. Oh, this is the first show. That clearly does not work. How about that one? Yeah, that's better. All right, there we go. All right. As Kelly starts off, the quickest way to second guess this decision to major in English is this: have an extended family full of Salvadorian immigrants and pragmatic Midwesterners. She continues, the ability to recite Chaucer in the original Middle English was unlikely to land me a job that would pay off my student loans and help me save for retirement. They suggested when I was a college freshman still figuring out my future. Well, your relatives were right. You should have studied computer science and not English. She goes on, I stuck with English, but when my BA eventually spat me out into the thick of the Great Recession, I worried that they'd been right. Yeah, they were right. After all, computer science degrees, and certainly not English, have long been sold to college students as among the safest paths toward 21st century job security. Still is today. It's still one of the safest bets. Top 4 degrees: computer science, computer engineering, electrical engineering, and software engineering. Um, but there are other degrees: IT, mechanical engineering, civil engineering, agricultural engineering. Those are also good paths to follow as well. Each of them will give you a pretty stable career. She continues, coding jobs are plentiful across industries, and the pay is good. Yes, they are. They're good to start. They're good over a career. Your salary will increase. Uh, Even after the tech layoffs of this past year. Yeah, and here's another thing about these types of jobs. Uh, they are these are the types of jobs that you want to have during up markets and down markets. When the market is good, obviously every job is safe. But when the market goes down, a company starts to make cuts. And where are they going to make cuts? They're going to make cuts at jobs that are not producing goods and products, right? I guess those be kind of the same thing if you want to look at it like that. So, for example, more recently at Amazon, Amazon was cutting jobs, but they weren't cutting jobs that they weren't cutting engineers. They were cutting jobs in up in HR. Those are the types of jobs that they were cutting, right? They the jobs they kept were the jobs that were filled by people that could maintain their current products and that could design and build new products. Those are the types of jobs that you want to have through up and down markets. All right, we'll continue. The average starting salary for someone with a computer science degree is significantly higher than that of a mid-career English graduate, according to the Federal Reserve. Yeah, that's right. That should be correct. We don't even have to look at this. The reason why, again, this comes back to skill set. What type of skill sets is the market demanding, right? The market demands computer science skill sets, electrical engineering skill sets, uh, software engineering skill sets, computer science skill sets. These are people who can design, program, um, let's see, maintain products. So these are the types of jobs that are stable. These are not easy jobs to obtain. These are not easy degrees to obtain, but these are the types of jobs that are well worth the pain and suffering that a student has to endure through their college career. We'll continue. She says at Google, an entry level software engineer reportedly makes $184,000. She doesn't say a year. I'm assuming that's a year. And that doesn't include the free meals, massages, and other perks. All right. After 184,000, that's all you need to say. Don't need to say anything else. None of the other stuff is important. Yeah, it's cool, but really, you're looking for the paycheck. Now, this type of job that she mentions at Google, this is a this is not a common job, or rather, these jobs are in short supply. When you get your typical engineering student, when you get out of school, you're not going to get this type of job. The This going only going to be a select few. And by the way, I really wouldn't even worry about that. If you're a student, you just graduated, you got a bachelor's of science, let's say in software engineering. I wouldn't even worry about that. Get your first job. Your your starting pay is probably going to be around 60,000. That I'll be honest with you, that's not bad. No matter where you live, you need your first job so you can start gaining some experience. That's what you need. We'll continue with this. And okay, so she said, and that doesn't include the free meals, massages, and other perks. Perhaps nothing has defined higher education over the past 2 decades more than the rise of computer science and STEM. Yeah, because that's what's built our civilization, our society. The nice things we have, the cell phones we have, the the cars we have, the amount of tech that goes into a car. It's not just the mechanical and electrical engineering anymore that's involved in the design and production of vehicles. It's also the software engineering now that is inside of it. Um, if you ever see like an engine light or you something like that with your car, right? Well, that software that's inside that software that was notified by a sensor and then from there that's related to the dashboard, and then that tells you in more older cars, like a vehicle I have, uh, I would actually have to take it into a shop or go on Google and find out what that light means, and I know how to do that because I taught myself how to do that. But in the newer cars, they will give you more information, right? But either way, you take it in the shop, they hook it up, to a device, and that device is going to tell them what's going on with their car, and that's the software that is talking back and forth inside the internal hardware. So uh, you need people to do those jobs. You need to fill those jobs. Those jobs require degrees, electrical engineering, computer science, software engineering, uh, so on and so forth. And you'll get so sick of me saying that, but it's true. There are a lot of jobs in the market, and I would say academia does a really terrible job of conveying that to students in STEM. So we'll continue. Since 2016, enrollment in undergraduate computer science programs has increased nearly 49%. That's good. That's good. That needs to increase. The uh, the number of jobs in the market is increasing, right? I would assert, I don't know what the exact data says, but I suspect that there are a lot more jobs in the marketplace that require computer scientists, software engineers, and the like, or adjacent degrees or professionals. There are a lot more of those people in the market, or there are a lot less. Excuse me, there are a lot less people in the market that do those jobs than there are actually jobs in the market. In other words, there's greater demand than supply. There's a lot less supply than what's being demanded in the marketplace. So there's a job out there for anybody who graduates with that type of degree. You just have to be able to find it, and there has to be some match. There has to be some match between you and your potential employer. So we'll say, meanwhile, humanities enrollments across the United States have withered at a clip. In some cases, shrinking entire departments to non-existent. Yeah, this has to do with market demand, right? Uh, if you're a school that has a lot of money being donated by uh, outside forces, let's say you have a fairly large budget as a university, you're probably going to be able to afford these types of departments. But with smaller schools, um, y- you're going to put your money where the money is going to be, where it's going to go the furthest, right? You're going to put money in departments where there's a greater demand out in the marketplace. That's how economics works. That's how capitalism works. So there's the alternative, which, okay, if you want that. Okay, so we continue. But that was before the age of generative AI. ChatGPT and other chatbots can do more than compose full essays in an instant. They can also write lines of code in any number of programming languages. You can't just type "make me a video game" into ChatGPT and get something that's playable on the other end. But many programmers have now developed rudimentary smartphone apps coded by AI. In the ultimate irony, software engineers helped create AI, and now they are the American workers who think it will have the biggest impact on their livelihoods, according to a new survey from Pew Research Center. So much for learning code. All right. First off, don't believe in any surveys. Uh, General rule of thumb: surveys are not reproducible. Uh, Second, it doesn't matter what they think, it matters what the data in the market says. And that is the trend in the data. Is the number of jobs increasing in the market, right? Is the demand increasing in the market? Yes, it should, because we are continuing to become more technologically sophisticated, technologically advanced. Is our educational system keeping up with that? Are they supplying enough students to keep up with that demand? Probably not. Probably not. Uh, as an example, there right now, I believe it's 130 women graduate from college versus 100 for every 100 men. The rate at which men are going to college is decreasing. And you would say, well, Mr. Engineer, why is that important? Aren't women going into STEM? Yeah, that's probably increased. It's not a bad thing. Absolutely. Women should go in STEM too. But there's other research that seems to indicate that women go into professions that don't involve STEM. So social work, uh, health fields would technically be a STEM field, I guess, maybe. Depends on how you look at it. Doctors, I imagine doctors might be. But they're going into the fields that don't include uh, engineering skill sets, right? I would include computer science in that as an adjacent field to engineering. If you have more women going to school, which is fine, and they're graduating at higher rates, but then the rate of men is decreasing, but men generally go into those types of fields, that means the supply is going to go down when the demand is going up. I don't know how you fix that. So, could be wrong, but I actually think I'm right on that point. If you provide me with contrary data, we'll take a look at it. So, ChatGPT cannot write a better essay than a human author can, nor can it code better than a garden variety developer. But something has changed even in the 10 months since its introduction. Coders are now using AI as a sort of souped up clippy to accelerate the more routine parts of their job, such as debugging lines of code. Yeah, okay. That's a long ways off from replacing engineers or being concerned that AI is going to take your job, right? I mean, those things are so far apart right now. In one study, software developers with access to GitHub's Copilot chatbot were able to finish a coding test 56% faster than those who did it solo. Okay, so what? Most of people generally people generally equate programming uh, to computer science or software engineering. Programming is a tool in the toolkit for software engineers. It is not equivalent to. It's a tool. That's like saying the the Phillips screwdriver is equivalent to the mechanic. It's a tool that the mechanic uses when the mechanic needs it. Right? There are a lot of other tools in the toolkit which computer scientists and software engineers use on a daily basis. A lot of it is going to meetings, reading documentation, communicating with fellow teammates who are other software engineers, communicating with engineers on adjacent teams, depending on the company that you work at. And there are other things that go on as well. Designing, fixing problems. Sometimes an engineer can go a day without doing any programming. That's not uncommon. So this idea that they're the same thing, that's just simply not true. So I can tell you from experience as an engineer, many of my days have been involved just doing mathematics. I didn't touch any lines of code. So I did afterwards, but I need the mathematics needed to make sense in order for the program to make sense and for it to actually solve the problem. Just to give you some insight. All right, so then she continues, in 10 years or maybe 5, coding bots may be able to do so much more. Yeah, they might be able to. And they probably will. And that's not a bad thing. It's just going to be another tool, which software engineers will use in order to be more efficient in their daily tasks. She says people will still get jobs, though they may not be as lucrative, says Matt Welsh, a former Harvard computer science professor and entrepreneur. He hypothesizes that automation will lower the barrier to entry into the field. Okay. I'm not sure that made any sense, but okay, we'll go with it. More people might get more jobs in software, guiding the machines toward ever faster production. This development could make highly skilled developers even more essential in the tech ecosystem. All right, let me tell you about development. Development is only as good as its design. You could design a terrible system and none of this stuff will work. It doesn't matter what type of AI you have, it does not matter. It's your design. And your design comes from, and you'll hear this when you get in your programs, software requirements or requirements. Other fields have requirements as well. Systems engineers write requirements, electrical engineers abide by requirements, design engineers abide by requirements, test engineers abide by requirements, not just a software engineering thing. This is an idea that's prevalent throughout, as far as I understand it, most engineering fields, if not all of them. But development is only as good as the design. Your bridge can only be as good as your design, or else you're gonna build a crappy bridge and it's gonna fall down, right? So these things go in order. Her writing lacks an understanding in this process, which is exactly why we're reading it. And this isn't a mark on her. I'm just using this article to illustrate the point that these are the types of things that software engineers and computer scientists, all engineers across the board, need to consider, right? As a future engineer, these are the types of things that you should start thinking about when you're going through your program, right? It doesn't even matter if you're just a mathematics student. And there's nothing against mathematics students. That's my undergrad, right? When a mathematician writes a proof, they have to think about the type of proof they're going to write if it's going to make sense. They just didn't jump into it. Oh, AI is magic. It's just going to make everything happen. No, that's not how the real world works. That's not how that's not how this works in engineering. All right. So she continues, this development could make highly skilled developers even more essential in the tech ecosystem. But Welsh also says that the expanded talent pool may change the economics of the situation, possibly leading to lower pay and diminished job security. No. Job security depends on your skill set, and it depends on supply and demand. Again, I haven't looked at the numbers, but my assumption is that based off of what I've been observing in the market, and again, what I've observed myself isn't the same as what the data would say from like Bureau of Labor and Statistics and so on and so forth. But uh, your job prospects, your job security is going to depend on that. Go look at what the unemployment rate is for engineers in general. Go look at it. See what it is. I bet you it's a lot lower than the average. And if the average right now is like 3, maybe 4%, engineers might be 2%. And 2%, that's just people moving from job to job and people looking for jobs. That's all that is. That's all that is. And people are not hurting for jobs in these fields, right? Technology will only solidify your position out in the market because now you're going to have to learn another skill, which is going to make you even more important. That's all this does. My my spidey sense tells me this is going to grow the market. It's not going to decrease the market. It's going to increase the market prospects for software engineering, computer science, and all the supportive engineering fields. If mid-career developers have to fret about the automation might soon due to their job, students are in the especially tough spot of anticipating the long-term implications before they even start their career. Yeah, excuse me, absolutely. They're going to spend 4 years at a university and they're going to spend tens of thousands of dollars. And afterwards, they're going to have to after they graduate, they're going to have to find a job. Now, what job is likely to help you pay your loans off? What job is that? Is that is that a person who graduates with a degree in English or degree in sociology, or is that a person who graduates with a degree in electrical engineering or a degree in computer engineering? Out of the out of those four degrees, which degree or two degrees, and there is a right answer and there's a wrong answer, which degrees are going to allow you to be able to live in some comfort and stability while paying off your student loans? And you're not going to have to worry about anything. There is a correct answer. All right. So here's a quote. The question of what it will look like for a student to go through an undergraduate program in computer science, graduate with that degree, and go into the industry. That is something I do worry about. Timothy Richards, a computer science professor at the University of Massachusetts at Amherst, told me that's not something I worry about. I don't worry about that at all. I mean, if you don't want to go to school and you want to do something else, then you should do that. I would say go into the trades. Trades make good money, right? You don't pay any, you're not going to have college debt, and you're going to be able to earn a really good wage. No matter if it's in welding or if you're as an electrician or something like that. Yeah, there's alternatives to the university. But if you go to the university, uh, there are certain degrees you want to study, and computer science is one of those degrees. Job market is not shrinking. All right, so I disagree with Timothy. He and I disagree. If he was your advisor, he would tell you maybe computer science isn't such a good idea. If you pick me as your advisor, well, what do you think I'm going to say? Yeah, uh, study computer science if you're interested in that, and here's the program, and here are the adjacent fields that courses in the adjacent fields that I want you to take in addition to that. I want you to work hard, and I'm going to help you. I'm going to help you develop the toolkit in order to be successful in college and after college. Because you're not just going to focus on computer science, you're going to also focus on building your talent stack. That's what you're going to do, right? You're going to be a wonderful computer scientist or software engineer, and I'm also going to provide you with links to the skill sets that will help complement that. All right. So let's continue. Not only do teachers like Richards have to wrestle with just how worthwhile learning to code is anymore, but even teaching students to code has become a tougher task. ChatGPT and other chatbots can handle some of the basic tasks in any introductory class, such as finding problems with blocks of code. Some students might habitually use ChatGPT to cheat on their assignments, eventually collecting their diploma without having learned how to do the work themselves. All right. This sentence is very simplistic. Now, is there cheating happening in universities? Yes. I've had conversations with administrators and professors, both at the undergraduate level and the graduate level, where they have shared their frustration with me, um, because we were talking about study habits and suffering and things. I don't mean suffering as in like you're going to be like stick needles in your arms or anything like that. All I'm saying is that these fields are hard. It's hard. This stuff is hard, and when you cheat, it's easy. Yeah, you do lose something from that if you cheat, right? You There's something to be said about having to go through it, and maybe you didn't get as good of a GPA, right? But you busted your butt, right? Uh, that's 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 respectable. I mean, that's more than respectable. That's the right thing to do. So, but even if some of these people cheat, and they do, they're still going to get something out of it because they're not cheating the entire time. At least I don't think they are. But will they be behind when they go out to the market? Yeah, they'll be behind. Will they be able to have conversations with other people in industry or hiring managers? They're going to be at a significant disadvantage versus the other students that worked hard and did the things they were supposed to do and didn't cheat. So yeah, we'll continue here. Richards has already started to tweak his approach. he now tells us his introductory program students. He tells his introductory program students to use AI the way a math student would use a calculator, asking that they disclose the exact prompts they fed into the machine and explain their reasoning. Instead of taking home assignments, taking assignments home, Richard's students now do the bulk of their work in the classroom under his supervision. I don't think we can really teach students in the way that we've been teaching them for a long time, at least not in computer science, he said. Well, I don't know. How did professors and teachers deal with it when calculators came into the classroom? I imagine they would be something similar to AI. I mean, in my opinion, AI is just an advanced calculator, but that's just me. It can do some really cool stuff, and then other stuff, it's like you don't want to use it. Some people with AI, a lot of people are they are. Well, let's see. This AI is the shiny object syndrome for them, right? It's the Ferrari. Again, AI can do some cool things, but it's um, it's something that people are just going to have to adapt to. All right, we'll continue here. Fiddling with computer science curriculum still might not be enough to maintain coding spot at the top of the higher education hierarchy. Prompt engineering, which entails feeding phrases to large language models. Oh, I went too far. Where are we at? Large language models to make their responses more human sounding has already surfaced as a lucrative job option, and one perhaps better suited to English majors than computer science grads. No, because prompt engineering involves a skill set, an engineering skill set. You need an engineering skill set to do prompt engineering. Um, well, not necessarily. I would say that it would be more advantageous for engineers, though, to use it because as an engineer, you'd kind of know what to ask for. You'd have an idea. With English majors, probably not. And by the way, for prompt engineering, if this is going to be built by engineers, engineers are always going to build it for themselves. I mean, that's notorious. That's why a lot of products fail out in the marketplace is because engineers build it for themselves and nobody else knows how to use it. So I can imagine like prompt engineering is built by engineers for engineers. They're not going to build it for English majors, and English majors don't know how to build it. So there you go. Uh, so there's a quote: "Machines can't be creative. At best, they're very elaborate derivatives," says Ben Boyce, an AI lecturer at Columbia University. Yeah, absolutely. So there you go. All right. She goes on here. It's kind of interesting. I'll read the last paragraph and we'll wrap this up. She says, in that way, the answer to the question of what happens next in higher education may lie on what the machines can't do. Royce pointed me toward Moravec's paradox, the observation that AI shines at higher level reasoning and the kinds of skills that are generally considered to reflect cognitive aptitude, think playing chess, but fumbles with the basic ones. The curiosity driven instincts that have always been at the root of how humans create things are not just sticking around in an AI world, they are now more important than ever. Thankfully, students have plenty of ways to get there. All right. So, I don't actually think her title is computer science is no longer the safe major, but I actually think she proved the opposite. But yeah, I mean, no, computer science is a necessary major, right? If you want to make a good salary and you want to have some stability and you want job opportunities in the marketplace, computer science is the way to go. I mean, there's obviously other fields as well, but sticking to the topic of the day, yeah, I would say computer science is a very safe way to go. Uh, you could take computer science and do a mathematics minor. You could do computer science and do take some engineering courses, electrical engineering, computer engineering. Yeah, it just depends on what you want to do, what your interests are. The technological field, or computing field, as we call it, is wide and diverse. Everything from data engineers and building infrastructure with AWS all the way down to embedded systems and writing software for hardware inside of vehicles. It's not just automotive vehicles. There's industrial vehicles, military vehicles. Uh, let's see, airplanes, stuff like that. And a lot of that includes the same type of skill set. So yeah, there's a lot of opportunity, and you're not just going to be secluded to the United States either. You can go all around the world and utilize these skills. I have people I've talked to from all over the world that have a similar skill set to me, and they're asking me questions about the job market in the United States. So, and I in turn ask back about job market in their countries. So, a lot of opportunity uh, in this field. And if you have any further questions on computer science and how one might go about getting into computer science and what the field entails and what the job prospects look like afterwards, please let me know. Uh, Go ahead and put your questions in the comment section below. Like, share, and subscribe because it does feed the algorithm. You can also follow me on Twitter at EngineerIDE. I'm the engineer. Thanks for joining me, and I will see you Monday night. Just as a note, I will be here every Monday and Thursday night from 7:30 to 8 p.m. Central Standard Time. All right. Have a great evening. Most importantly, have a wonderful Friday and have a great weekend. I'll talk to you soon. Take care. Be safe. Bye.